Hi everyone. This is a recording just to show you an example of the story enclosure method and how it might be asked, or the things that you need to consider whenever applying the story enclosure method. So I've got a nice question here that I set up this afternoon. So what you can see here is, okay, this is the example. I see there's a mistake here. I'll just correct that. Okay, so you've got a typical question of a drawing that is given, and then you have some different criteria surrounding it, and so on. So the question reads, figure 1 shows a proposed office building to be constructed in Bloemfontein, and then the first question is calculate the story enclosure surface bed factor and assume that the excavation depth is 1 meter and that the top of the concrete surface bed is 300 millimeters above the natural ground level. So if you look at your example 5 of your study notes, you will see that it's similar to this, and it's a combination of all the preceding examples before this one. So that's question A. Question B is calculate the story enclosure factor for the external and internal walls of the building with the following details. Okay, and then you are given certain perimeters. So you can see there's 4 windows of 800 by 1.2 millimeters high. You've got 2 exterior doors, and you've got 5 interior doors for this specific drawing. So that is the question 2, or B. Question C is use the story enclosure method to calculate the basic building cost for the building below. So use the calculated factors in A and B for the surface bed and external and internal walls, and assume the story enclosure tariff that should be applied to this question is 3,000 Rand per square meter. Okay, so those are the parameters that's given and the example that's given. Then looking at the drawing, the available information that we've got certain dimensions given. We're given the two just basic information of the exterior walls is 220 millimeters and the interior 110. We've got an IBR roof with a pitch of 1.5, so that's very important to take note of. We've got floor to ceiling height of 2.4 meters. Okay, and then we've got standard finishes. Okay, and then we've got the external perimeter, and we can see, okay, the blue hatching is some paving also included in this drawing, and then we can see that the height from the natural ground level up to the roof plate is 2.8 meters. Okay, sorry, not from the natural ground level, from the top of your surface bed up to your roof plate is 2.8 meters. Okay, so yeah, that's the basic information that's given. So let's have a look at question A and how to approach these questions. So I've just copied this example into Excel spreadsheet to make it available also. So the first question is calculate the story enclosure surface bed factor and assume that the excavation depth is 1 meter and the top of the concrete surface bed is 300 millimeters below the natural ground level. Okay, so now you know if you need to calculate your factor for your surface bed, the following formula has to apply. So we know this is the formula that we have to use, so this is one of the formulas that you have to know. Okay, and obviously you need to know where that D is the depth for the excavation in meters, and H is the height for the filling in meter, and then L is the length of interior and or the interior and exterior foundation walls combined, so please take note. And then you've got your area, which is your surface bed area that you will use. Okay, so then you basically just calculate or populate your formula. So then you go through the basics of just measuring your work. So I'm just going to put this on. Okay, and then you just calculate your perimeter walls, you measure that. You go through your interior walls, you measure that systematically, and yeah, you just measure this systematically, and you get your length of your walls. Sorry, I'm not going to do all of it because it's just going to be a bit time consuming if I do go through all of this, but basically you just go through the measurement of your lengths of your walls. Okay, so later on you will use these lengths again when you're calculating your area of your external walls and the area of your internal walls. So yeah, just be aware of that. Okay, so I'm just going to put this aside and then look again at our length. So the length of our wall, I calculated it as 80 meters, and then the area of our surface bed is basically 10 plus or times 12, which gives us 120 square meters. And then our depth of our filling and height, this is where you have your depth of your excavation plus your depth of your surface bed or your filling above your natural ground level. Okay, and then you need to remember to deduct your surface bed 0.75 as well. So if you look at your examples, it just clearly shows you how that is done. I think it's in example 4 of your study notes, so have a look at that, how this height is calculated. So it's explained there in quite good detail. So yeah, just be mindful of that. Hi everyone, sorry I just took a small break there, so I thought maybe it would be best if I just make a quick drawing of how that depth is calculated and how everything works into each other. So here you can see your excavation is the depth is 1 meter, and then the 300 millimeters for your surface bed above natural ground. Sorry, that should actually be up to there. So it's the 300 mils up to the top of your surface bed. So there's a little bit of a trick here. If the question states to the underside of your surface bed, then you don't have to subtract this 75 millimeters. But this is in short how that depth is basically calculated. So yeah, you can familiarize yourself, as said, with the example in your study notes as well, but this is more or less for this example how that works. Okay, so getting back to the example, we now calculated our depth, is our depth and filling and height, our filling height. So it's 1.225, so you can round it to 1.23, and then what you then do is you calculate your factor by just populating your formula. So it's a 0.4, and then your length of your walls divided by your surface bed area times 1.23 divided by 2 plus 0.01, and then you just add the 0.4 there at the end, and this is basically the formula, and you get a factor of 0.88. So that's the first question answered. So have a look at that. And then the second question is calculate the story enclosure factor for the external and internal walls of the building with the following details. Okay, so now we know it's the internal and the external walls, so two formulas will apply. So we've got our first formula, which is in your book that you have to know, and your second formula as well for the 110 millimeter wall. So you've got your percentage of windows and doors that you have to calculate, and your borrowed lights as well. Okay, so let's first look at our 220 millimeter wall. So you can have see here that we've put in the standard for the square meter area for our external walls. So that is now, if we go back to our drawing, let me just put on this one. Okay, so if you have a look at this one, it's basically, if I just convert that back to black, or let's make it purple. So it's the purple lines for this section here. So you should remember that it's the walls over your doors and windows and up to your wall plate level here. So, and then you have to add your gable wall into that as well. So just take note of that whenever you're calculating that. So I've divided that into our standard one, which is basically our walls up to wall plate, and then I added the gable walls later on. You can combine the two, but it's usually better if you just calculate them separately, so that you can, if you do make a mistake on the one, whoever is assessing the question can actually see what you've done. Okay, so I think the standard walls is quite simple. It's the perimeter times the height, which is in this case is the 2.8 meters. So it is, if we go to our drawing, you will see it's the 2.8 meters here to your surface bed height. Okay, so that one should be fairly simple. And then the gable wall ends, this is where you need to use your trigonometry formulas. So what I've done is, we know that our length on this side wall where the gable wall end is 10 meters. So we want to have a 90-degree angle that we can actually use. Let me just see. Yes, here we go. So we want to have a 90-degree angle, so we divide that section into 2 to get our 90 degrees, and then which is then 5 meters. So it's the 5 meters times tan 15. Just make sure that you know how to use your calculator, whether the 15 comes before the tan or behind the tan. These days most scientific calculators have the tan afterwards, so it's quite easy to use that. And then you just calculate what the height is here. So now you've got your height, your breadth and your height. So you can actually calculate now your area by just timesing these two with each other. And also note that you've got, if you times it with 2, you will actually have the entire gable wall section on this side. So I just times that with 2. Here we go. So it's the 5 times the 1.34 times 2 to get our gable wall end areas, and we just add those two together to get our total wall area. Then you just populate your formula. So in the question it was stated that we've got 4 windows and 2 exterior doors. So you just get that perimeter, or that perimeter, the area of that windows and your doors, times 100 to get it to a percentage, and then you divide it with your total wall area, which is 136.6, to get to a percentage. Okay, so that's the first step that you need to do. Okay, and now you can populate your formula, which is 0.6 plus your percentage divided with 130 according to the formula that's given. Well, not given in the question paper. You need to know the formula, and you get a factor of 0.64. So you can see our external walls actually has a much lower contribution to the total, or a lower factor than a normal factor of 1. And then we just do the same with our internal walls a bit quicker, because we've got our internal walls. If we go here, which is the ones in red, you just get that length, and we know that it's up to ceiling height, which is 2.4. So it was built up to there. So we just calculate our ceiling height. So it's the 16, so I used the north to south walls first times 2.4, and then I just added the east to or the west to east walls, and just added them together and times it with the height to get to 86.4. Okay, and then the percentage again is the information given here at the top. So we've got 5 interior doors. So we've got our 5 interior walls here, the perimeter times 100 divided by the area of our internal walls, which gives us a percentage of 9.56. And then that is put into our formula, which is 0.44 plus 9.56 times 143, or divided by 143, which gives us a factor of 0.51. So this one, the interior doors, is still fairly close to the 0.5. Okay, so those are the two factors for our internal and external walls. And then we get to our third question, which is to use the story enclosure method, calculate the basic building cost for the building below. Use the calculated factors in A and B for the surface bed and external and internal walls. Assume the story enclosure tariff to apply is 3,000 Rand per square meter. Okay, and this is excluding VAT. Okay, so then you just go ahead and you calculate what your surface bed area is, your roof area. We've already calculated our wall area, our internal wall area, and then we just apply our factors. Just remember, with our roofs, we've seen that it's an IBR roof according to the drawing. There's the IBR roof, so we know it's a standard roof. So if you go to your study notes, the standard factors that that you will use for your roofs is contained on page 12, and you will see cement tiles is 1.25. and our corrugated iron or asbestos roofs are 1, so I used the corrugated one for the IBR roof, and subsequently did the calculation. So the factors were put in, the ones that we calculated already, plus the one for the roof. Okay, and then we calculated our story enclosure area. And then it's a simple thing of just timesing our story enclosure area with our tariff to get to our basic building cost. Okay, so this is everything up to our basic building cost, so you can have a look at that. And then just as an extra note, this section in red is something that might be asked additional. So now we've calculated the additional or the basic building cost, but now we want to calculate what the actual cost of the building would be. So you would see that on the drawing there's some paving here on the side that was added. So if we take it at a rate of 520 Rand per square meter, we just calculate what the external value would be as well, or the paving contribution would be, and we get the area and we times it with the 520 to get an additional 11,960 to be added to our basic building cost here. And then it's a simple thing of just adding our P's and G's, getting a subtotal first, very important. I see very many students actually trying to add this without the subtotals. You have to add the subtotals, otherwise you can't calculate your contingencies, and then you can't calculate your VAT if you don't have a subtotal for that also. So our estimated cost for the building, not our estimated basic cost, our estimated cost for the building is now 1.54 million, which is including VAT contingencies, and P's and G's. So just take note, this might be an extra little section in the questions that might be asked. So yes, in short, that is how a typical example of the story enclosure method works. Very similar to example 5 of your study notes. And yeah, so work through this one. I think it should be a nice one to practice. Thanks everyone.